Welcome everybody to Dallas Programmable Robotics Group Robot Builder Night Virtual for December 9th, 2025. Tonight we will do our normal robot presentations and then open it up to open mic. A little bit of housekeeping we're talking about as well. We're taking input into whether we're going to have a December Tuesday meeting on the 23rd and whether we're going to have a monthly meeting on the 27th. So think about it, and maybe we'll discuss this later on in the meeting. For now, we have Ray that has a small presentation to go, and maybe we'll follow through and see what's happening with Ray, and then carry on. We've got one other presenter for a little later.
Anyway, the what I've been working on, it's actually for the outdoor robot. I had two, let's see if I can get my phone up to use it as a portable camera. DPRG website.
The main website for the Dallas Personal Robotic.
Come on. Here we go. Okay, join here too.
Hey, Mark. I have a question. When you guys went to Moon Day, you had a special T-shirt. Did you have a T-shirt?
No, I did not.
Okay, I know John did. John, did you have a T-shirt?
Yes.
Yeah.
I have it somewhere
Could
around.
could you take a picture of the front and back of it and send it to me?
I will. Yeah.
I've got some that I've got up on the web now, but
As soon as I can find it offhand, I don't know where he is. I'll look.
okay. Go ahead.
Okay. I pinned myself. Whoop, here and there. Okay. Darn. I don't know how to get rid of the echo. Oh, let me try this. Okay, is it echoing? Oh God, that's worse.
Yeah, I just need to turn down the volume on one. Mute one, volume the other.
Okay. Yes. Oh, okay.
Yeah.
Okay. Any better?
Yeah.
Okay. All right. So I actually had two of these. These are the pulse light lidars. They don't rotate. It's just a fixed point. Yeah, I have them on servos and rotate them that way. But one was version 1, the silver one, and the other was version 2, the blue one. And they actually had different libraries for both. So, it was kind of difficult to say, okay, and the names are all very similar. So it's kind of difficult to separate all that out. So one of the modes that you can put it in is it's just a PWM mode, and you can trigger it, and 20 milliseconds later, you can read it and or actually have it do, like through interrupts on the processor, time the pulse with pulse to figure out, because that's proportional to distance. So you could, convert that over from pulse width to a distance. And that seems to be about the easiest way to do it. And it's kind of weird. They don't really say that you should wait 20 milliseconds before you read it, because you'll get garbage out if you do. But in their code, they have, delay 20, so, and, using like, Copilot and doing searches, that seems to be the way that you use it. Otherwise, it won't work that well. Anyway, so what I can do is plug everything in here. And I guess that's the most interesting thing. I have to get the Arduino IDE up. Hold on a sec. Come on. It's taking its time. Oh, recent.
Doug, I just emailed you the Moon Day graphics.
That one. I think this is the one. Tools. I'm going to do serial plotter. Okay, so let me see if I got to share my screen. Screen. No. Window. Okay. Can you see that?
Yeah.
So that's the two pulse lights just firing off what they're seeing. One's at like 270 centimeters, 2.7 meters, and with the other one's just a little over 3. So if I stick my hand in front of the one, it shoots down to about 50 or so, which if it was at 30, that would be like a foot. And the other one isn't affected, and then I can kind of change it or scan through my fingers. And so that all seems to be working okay now. So it's using interrupts, and it is using the micros function in that, but it only calls it once. And to kind of protect the variables, you can do like no interrupts and interrupts, before and after you access the variable that it actually changes. So, but it's only, for a slight period of time, just on the rising and falling edge of each pulse width from each of the two. And I tried to sequence them so they're a little bit apart from each other. So the likelihood of interrupt service routine contention is minimized. So, but it seems fairly reliable, as far as what you can do with it. Anyway, I wanted to get updates, as often as my PID loop works, which is 50 milliseconds, 20 times a second. So this actually takes like 25 microseconds, because I trigger one, wait 5 milliseconds, trigger the other, and then in 20 milliseconds time, read the first one that was triggered, and then the second one. So the it's oh, there we go. Uh-oh. Looks like I have encountered an issue here. One of them is not responding anymore. Yeah. Dang Damn. Oh, there we go.
Zero.
That's
Lose
It
what?
looks like is your value two the higher Rev one?
let's
Is it the
see.
one with the blue label?
Value one is actually the older one, the silver one,
Yeah.
and the blue one is
I don't know if you saw that, but you had a spike on the orange one, and it went up to 350,000.
Yeah. Yep. Yeah, that I've seen that happen occasionally. I don't know if that's a misread or a serial port overload. Of course, I won't be using, printing out values to over serial. I'll just be using the variables and not printing them out. But Ugh.
They
Okay.
use I squared C, right?
This does not. You can with these, but one of the things that you're supposed to be able to do, you couldn't do it with the version 1 ones, but you could with version 2 and on, supposedly, is change it. Change the address. When you power up, there's a power enable pin that you're supposed to pull low, give it another address, and then pull it high. But that does not work. And I thought going with I'm going to see if I can restart it. Well, anyway, I can do that offline. Yeah. So the old one's a lot more reliable than the new one, apparently. Anyway, so that's what I've been working on. And it looks like my work's not done. So, anyway. So it was, like I said, it was working okay. I guess maybe it's demo mode or something. But
well, I think too, Ray, your thing went to 0.
yeah,
Your reading went to 0, where before it was reading, when you went down, it was like a minimum of 10 or something, 50 or something. I can't remember. Maybe you got a loose wire and it just stopped working.
oh, that could be. Yeah, it's kind of a flaky setup here.
Yeah.
Tools, monitor. Yeah, it's stuck at 1. Darn. Yeah, even I don't know if you can see that streaming by, but the serial port stuff is. Yeah, the one is still working, but the second one isn't. Anyway, okay, I'm going to sign off on my phone here.
You're muted on your other microphone, Ray.
It's there somewhere.
Yeah.
There you go.
Okay, can you hear me?
Yep.
Okay, I can't hear you.
There you go.
Okay. Anyway, well, that's a little disappointing. Thought I had this all fixed. Damn.
Demo effect kicks in again, eh?
Yep. So, like I said, was working. I don't know what happened. It is kind of a flaky setup, using DuPont connectors and everything, and lots of, air wires hanging out all over the place. So maybe I did yank one out. Anyway, so that was the idea, is to try to incorporate that, to try to get the measurements in for every PID loop. So it wouldn't, there wouldn't be significant lag there. I did purchase another one, the Benawaki. Let's see, I think it's a mini, I want to say TF. It's similar to the ones that Scott is using on his. And those, I think you have the option of serial port or I2C. And
Yeah.
I also had, I thought about using them. I bought some Adafruit. It's a 4-channel I2C mux. Yeah, and I guess there's an 8-channel that she makes as well. But I thought about doing that, and then you don't have to work with changing the address that never seems to work anyway, and just putting them on 2 separate buses and doing it that way. Because there's 2 I2C ports on the ESP32 processor that I'm using, and right now the other one has the B&O 055 and a GPS receiver. So, and those 2 are connected with quick connectors, and that's been pretty reliable. And I don't think I could stick one of these, using an I2C bus on that bus, and then stick the other one on the other I2C bus, and then that way I wouldn't have to worry about trying to change address and have different libraries that aren't compatible and all that kind of stuff. So, but anyway, and I think I don't know I think Scott is using them in serial port mode. And
so I know I am.
Oh, you are?
Yeah. That's why I'm using the Teensy, because it's got 7 serial ports.
Oh my God, it does. Wow.
It makes it fairly easy.
Super easy, yeah.
Yeah, and very reliable.
Yeah.
So, I think what you're thinking of is the TF Mini Pro, which is
TF Mini Plus.
Yeah.
Plus.
Yeah. And that one is, like I say, I had a lot of problems with my robot, but it wasn't from them.
Really? Okay.
Yeah, those were a champ. They just worked. They were easy to set up, and they just worked.
Yeah.
So, I've been experimenting with a lot of these little dinky, made for drone type TOF ones. They're also, I think, if you go down deep enough in them, they're probably being a wiki, but they might not be. But they're actually so small that they're hard to work with.
Oh, really?
Yeah, because they're made to be put on drones.
Oh, okay.
And I mean, we're talking something really, really light and really, really small. And the physical, just handling them physically, is a bigger pain than using the ones that like Scott used.
Yeah. And even those aren't that big. I mean, they're probably a little over, I don't know, close to 1 inch in one dimension, and probably a little over 1 inch in the other dimension.
Now, Bennywig makes one, which I believe they call the Nano, which actually has think of it as 1 bit, but it's 8-bit wide. Okay, so you have a little more. It essentially artificially creates a wider cone in the horizontal direction. All right, now I've got one to play with, but I haven't actually, other than to say, that's interesting. I haven't really done much with it.
Yeah. So you can actually change the shape of the cone somehow?
No. It's still, you get one reading. So it's the closest reading, whatever it is. But instead of being a 2 degree by 2 degree spot, it's a 2 by 16 spot. Okay. So it's a little, that's the only one I think they make like that, but it is a little different.
Yeah. That sounds interesting. Yeah. So in essence, you can get a line of readings. Are they all?
You only get one reading. you only get one reading. But
okay.
It's taking its input data from eight spots.
Oh, okay. Huh.
Okay. And so it's not like what Mike was using, where you have an 8x8 array and you get 64 readings back. No, it's not like that.
Okay.
But most of I think the big problem you potentially have with the TF Mini Pros is that, since you're only looking at a 2x2 degrees field of view, you can, you don't have continuous coverage over the front. You just got 3 samples that you're looking at, or 2 samples.
Yeah.
So that's a problem. But Scott's made it work, and like I say, I've been real pleased. But it's surprisingly more robust than you think it would be.
Yeah.
Now he's doing some really clever stuff. If you looked at his robot, or the robot interviews, which, by the way, everybody, if you haven't been out to the website, the robot interviews and run things and everything and results are all out on the website. But anyway, he's put his 2 outer ones on servos, so he can adjust them. Depending on the situation, he's either looking outward or bringing them in to reinforce the center reading.
Right. And he actually has 3, right?
Yeah.
On the front of his, yeah.
Yep.
Yep. Yeah, these are a little bit, I guess, sloppier. It's got like a 4-degree, beam divergence, and so you do get a little bit bigger spot out there. So
and the range on those is really fantastic. If I remember right, it's like 60 yards or something.
40 meters, I think.
Yeah. Big problem.
I've tried it outdoors. They seem to work really well.
And they work good outdoors. Yeah, they were made to work outdoors.
Anyway, yeah, darn, I don't know what's going on. I'll take a look at it, I guess.
Well,
hopefully,
I know one of the complaints about the original one was that in I2C mode, that it had a tendency, because of some poor design, to lock up.
Yeah.
So the IC² bus would lock up on the whatever it is, version 1. So, but supposedly that was fixed.
Yeah.
In the next version.
Yeah.
So, but if you're using serial, then that shouldn't even come into play.
Yeah, I'm using, just pulse width modulation, or pulse width, output. So the processor, through interrupts, triggering on the rising edge, triggering on the falling edge.
Okay, so you're using the analog output.
Yeah, it's just a pulse width.
Or I don't remember. Maybe it's the digital output, but
yeah,
it's the one that just measures pulse widths.
Right, or gives you pulse width, and so yeah, but anyway, so I guess I'll have to look at that. That was kind of my goal, to get it to measure in the PID cycle time, which 50 milliseconds, and give me 2 readings, so I always have the latest data, and pretty much stop the PID loop on that cycle if it sees an obstruction, and kind of plan what to do from there. I think kind of one of the simplest things you can do is if you're looking at like a left distance and a right distance, what I've seen is you can set some threshold, and it's kind of arbitrary. I chose 1.5 meters out in front of it, so there'd be enough time to actually stop and not hit something and destroy bumpers. Now I forgot what I was going to say. Anyway, oh yeah, the looking at the left one or the right one, if your obstruction on the right side is closer, you want to turn away from it. So if it's obstruction on the right, turn to the left and vice versa. Or if you kind of get stuck in a spot where you can even have a shorter threshold, and you can say if you reach that threshold, you can stop and actually rotate in place until there are no obstructions, and then you can move forward and then go back to GPS, movement through GPS coordinates or waypoints.
Yeah, I think if the second and third run that Scott did this year,
Yeah.
we went to 3-waypoint only, and you can see in the first of this, so it'd be run 2. You
Yep.
see where his robot picked the wrong direction.
Mm-hmm.
And because of that, he was wandering. Eventually, if his robot had not needed a reboot, he would have gotten to the edge of the fence and then turned around and rolled over. But, luckily the second time he hit it so he could turn it, his robot turned in the right direction.
Right.
And that was because he came into the weeds at an angle.
Mm-hmm.
And he got 6 points very nicely.
Mm-hmm.
And then he ran into the problem that the third cone was actually on the other side of the house. So he was going to have to wall walk around the house.
Right.
And his robot is so robust, it just climbed up the step. And, that was he was gonna go through the back door and through the front door. He wasn't gonna do any of the wall walking stuff.
Yeah. Yeah, I think what it was, there's a pretty good incline there, almost to where the slab is.
Yeah.
And I think his LiDAR sensors were, pointing maybe up at the ceiling of the back porch and didn't see the slab there because it was, it's a wide open area.
Yeah.
And so
it
boom.
just rode up the stairs.
Yeah.
But it was a little too steep, so he kind of was going to fall over.
Oh yeah. Yeah.
Yeah.
Yeah. I don't know if he still had his tilt sensor on. He had a thing that said if you go so far back.
Yeah, he got burnt 2 or 3 years ago with his tilt sensor. So I think he's pulled it back so far that it's not being effective anymore.
Okay. Yeah. Anyway, I think they're pretty good sensors. I think the first one it was actually purchased like 10 years ago, 2015. Yeah. So is when they came out. But
when they came out, there was nothing that even came close.
Yeah.
Not even. Just that's why they got all that expensive glass in front of it.
Yeah. Yep. Anyway, so that was all I had. Partial demo, partial.
But are you intent to use those? Are you going to use them, Ray?
I think I am. Yeah. I've got them on servos as well, and I can mount them just on the inside of the wheels and have it either point out so that it'll catch an obstruction in front of one of the wheels, like at least a meter out. It depends on what angle you have them at, but then I thought I could also do what Scott did, is point them inward, so then you have like a kind of a triangular shaped protection zone. So if there's an obstacle in that, of course, the closer to the wheels they are, the shorter the distance is. So it's kind of like you can probably travel until you see an obstruction and then pull them in and see if there's also one right in front of you. I think there was like a green T-post on Steve's property at one point, and I thought Scott's robot caught it.
Yeah, there was a fence post, a little steel fence post that was just randomly in the middle of the yard for some reason.
Right.
And but it was it was within the it was one of the obstacles to the cone, and he didn't see it. He just ran right into it.
Right into it. Yeah. So I guess that's the thing of, you can't have them pointing everywhere at once. So you pretty much have to choose. And I guess you can even cross them if you wanted, cross the two beams. And then that way you're protecting the area in front of the wheels, but then you're not protecting the area right in front of the robot. That's going to be closer in because you're, pointing out crossed. I mean, yeah, there's going to be some protection there, but hopefully you can see it and react in time and, slow down, turn, do some evasive maneuver or something. So, but anyway, yeah, so it was kind of neat, kind of get these out, dust them off, and even some of the pulse light documentation, there's links to it, but they're dead links now.
That's bad.
There's nothing there. So
have you tried Chat GTP today? Were they able to give you any stuff?
Yeah, as far as some of the nuances, like they didn't use the same I2C addresses to read data on. And between version 1 and version 2, for some reason that got modified or changed. And Chat GPT didn't point that out initially. And then I just asked that. I said, okay, show me all the differences between, these two sensors. And it listed, oh yeah, so the address for data is, 0F on one, but I forget what it is on the other. I think it was 08 or something, or 8F, I think. So anyway, yeah, and I hadn't realized that at first and couldn't get the one to work, and that was the reason why. And so instead of using libraries, it's like you can still, there's code out there that'll still help you access the individual registers and what how to access them as far as what you do in the sequence to get something to work right. And, so that's what I was using. So I've been experimenting. I played around it with I2C mode, played around it with pulse width modulation mode. The code is much simpler with pulse width modulation, but got to have it a lot more reliable. Can't have one side just going on vacation in the middle of a robot run, and giving me a distance of 1 centimeter, so. But anyway, so that's what I've been working on.
Thanks, Ray.
Yep.
That was going to be a short presentation, and you definitely used up some time. Mike, are you ready tonight?
Sure.
Excellent. Mike was going to give us a presentation of he's working on a mini sumo robot.
Yeah, so I went to Dallas Makerspace and borrowed one of the arenas. I borrowed the lighter foam one to take home. The wooden one was pretty heavy, and I didn't want to scratch it up. So,
Yeah.
And this is
Gives
sort of the
it character,
competition. Huh? Yeah.
I said it gives it character, all the scratches and.
Yeah. And so this is the setup there. And so the robot is all of this junk in there. It's just for people's pleasure. The GitHub is, I'm going to put the GitHub in here. Yeah, I'm working on the documentation. So, okay, so I don't have an on-off switch. I just have a cable here. So I'm going, the battery's stuffed under here. And I'm just going to give a show.
So you're being brave there. That thing is pretty high up in the air.
Waiting for something to do. So it's
You
pretty
got
much
got good reflexes. You're going to catch it if.
Yeah. So I got my Poluna box, which is actually 10 centimeters by 10 centimeters, and I put in some hex wrenches just to give it a little heft. And so if everything is working right.
Nice.
Wow.
Yeah.
Cool.
Yeah.
Excellent.
So, well, the cat's interested in it. and so also, you know, it comes from the side, it'll and
So this was on sale for Black Friday, you said, or something?
Mm-mm. No, this is all homemade.
Oh, that's homemade. Okay.
Oh, yeah,
Okay,
yeah.
I saw the Pololu box. I thought this was one of the Pololu sales.
no.
That's a backup.
I think that's supposed to be my Palolo Zumu. He's planning.
So basically, you know, it can see on the side and turn towards it. The other side. I'm not sure if you can see it, but
A bit of a blind spot.
and nothing on the side. So I have an IMU on there that I'm going to use. If someone tries to whack me on the side, it'll respond to that. But I won't be able to see them coming, but when they hit me, I'll be able to detect that and run away from it or do something. And like on the back, works. Yeah. And so this is a Polulu box, but I'm not happy with my sensors.
So
So this is a my first prototype of the case, and it attacks it, but you can't see. It's invisible. Invisible to these sensors here.
Hmm.
They can only like these are the IR sensors. They can only see the time of flight sensor is the only thing that sees it. Like on the back.
Because of the black material, because it saw the blue box, right?
Yeah.
So the angle.
No,
Or
the
both.
black.
Yeah.
It's flat black. I mean, I picked flat black to be less visible, but so I might have to. I think I'm having a chance of winning someday. I need to put better sensors on it, like a bunch of time of flight sensors, because on the back it just doesn't see anything because of the black. So
I remember in the old days in the mini sumo like that and the sumo, they used to use IC chip foam. You know, the old black foam they used to use for anti-static on chips. They used to coat the outside of the robot with the anti-static black foam, and the infrared sensors wouldn't see it, and the ultrasonic sensors wouldn't get a reflection.
Yeah.
Yeah. So
Before they had stealth airplanes, they had stealth sumo.
So if you look at my if I share this, let me see. Let me share my screen. I'm gonna share my GitHub.
Yeah, you got some nice close-up pictures there. That's good.
So this is the README file, and so this is the CAD file that I basically showed last week, and this is basically what this is built on. So it's a solid one-piece body with mounts for all of the sensors and the motors and the circuit board. So it's just one print, and then this is the this is it. This is the at the same angle with the circuit board and the sensors and the wheels and battery and everything stuck in there. And this is like the top down. So you can see the motor mounts. The motors are here. Can you see the cursor I'm moving?
Yeah.
Okay. So the motors are here with the wires coming out. And then these are mounts. These are clamps for the motors that are bolted in. And this is the wheel well for the wheels. So the wheels are right here. You can see the bottom there. And then this is the front and back sensors, and buried down here are the line sensors. And there's 2 line sensors here and here. And the time of flight sensor goes through this hole right here. That's on a circuit board, and it goes through that hole. So this is sort of the circuit boards. You can see that I have all the cables plug into these nice clamped connectors. And the motors plug into 2 pinners, and all the sensors have 3 pins. And all the sensors are on off, except for the time of flight, which is a I2C. And I weighed it, and it's 224 grams. I wish it was heavier to have a little more traction, but I guess I could put a lead lid on it.
Well, hey, Mike, you always want to be at the top of the weight. You always want to be, because if the guy has a heavier robot, he has a big advantage over you. So if you find out that you're not close to the limit, you need to beef it up so that it's has the heft. I mean, I'm just saying that's
I think
So the lid, this doesn't have a lid, so I could add some weight on the lid, but there's really no room in there for me to add any weight.
Yeah.
Of consequence. The battery's probably the heaviest, one of the heaviest pieces, but the battery and the circuit board with all the components on it, like where's
a few grams, yeah.
It's about the same. It's about 50 grams, and the battery's about 60 grams. And the wheels are probably the heaviest one, wheels and motors. I think they're like 100. So that brings me up to that 225. And
what's the limit?
500.
500, I believe.
Wow.
Yeah.
Yeah,
So the
you
weight
don't
limit is
have
500, and I only have 225 without
Yeah,
a lid.
you gotta get your weight up. I mean, that's a tremendous advantage you're giving to your opponent.
Right. So I'm not sure how people make them heavier, but I guess put some metal on here.
Yeah, I always used to think lead was like the densest, material, but I think actually titanium is more dense than it. So if you really want to go for,
It sounds expensive.
yeah, lead is probably a lot cheaper.
I have a whole jar of pennies. I could glue pennies onto the lid. Okay, and so
Old penny racer style.
Let's get a little sock of pennies and start smacking the other person.
So this is the motor is a bigger motor would have helped, I guess, but this is a pretty good one here. It's a FingerTech Silver Spark. It's a pretty good motor, but it looks big there, but it's not that big. It's the small motor, and I was able to cut the shaft off with the hacksaw real nice. So that was yeah. So thanks for the advice on doing that. Oh, it says it's 28 grams. So yeah, so 2 motors is 50, and the wheels and the body, it added up to about 100. So yeah, and then the okay, where was I going? Oh, that wasn't it.
454 is a pound, so you're under half a pound.
Yeah, no. Yeah. So I'm almost halfway there. And so these are for mini Sumo. And so the motors and the wheels all fit together and they connect together and give you a width of 9.95 centimeters. And so you can see here that
So you got 5 whole millimeters to spare there. Huh?
centimeters, yeah, or millimeters. You're right, yeah.
Yeah.
It's almost a 1/4 inch.
Yeah.
Yeah, because if you look on here, they're not touching, so they could be a little closer. The terminals on the motors there, they're not touching. They're a few millimeters away, maybe 5 before they would touch. So
So you
So
have
that
5
you-
millimeters to spare. You
Yeah.
should put steel plating on the outside of the robot.
yeah, go to the metal shop and figure out how to make a metal. Oh, I'll make a metal lid of some sort, something heavy.
Yeah, but you probably want center gravity as low as possible too, right?
Yeah. but
Squeeze
But,
it in, it'd be better under.
But I put the heavy motors and wheels and battery at the very bottom, and there's just a little slice here for the edge sensors, and there's another slice there for edge sensors, and the battery goes from here to here. The motors go from here to there. I mean, everything. There's no millimeter to spare.
When your circuit board goes in there, is there room underneath it between the cutout and the front?
No, that's a battery.
Oh, that's where the battery slides in there. Okay.
Right. The battery comes in here, and you can't see it on that. Yeah. But this is where the battery goes in there. And so, and then the pins and the circuit board goes in here, and there's just a millimeter or so between the circuit board and the wheels and the motors. As you can see here that it's pretty tight. So and then the wires pop up, and so I can put a lid on and press the wires down. And this one circuit board here touches almost touches the lid, so it's a millimeter away or so. Yeah, and I packed that board tight. I need to get a good picture of the board.
You did good.
And and so the six, so basically I'm trying to document all the parts on here, and then this is the schematic of it. It's an RP2040, and I got 4 unused pins, and I sort of made sure that I could use I2C2 or a serial port if I needed to add something to it in the future. But all the sensors get a pin, and then the motor driver gets 4 pins, and so the power supply, you get the 7.2 volt battery, and then I convert it down to 6 volts, and then I put a diode on it. Instead of a Schottky, I needed to actually drop some voltage, so I put a 1N4001, and this gives me my 5. 5.5 or 5, and then that goes to the RP2040 and to the 3 volt regulator. The 3 volt regulator powers everything else, all the sensors, because everything is just a little too much power for the 3.3 volt output. It probably would have ran, but I didn't feel comfortable, so I gave it its own little regulator. It's a little teeny regulator, sort of hiding under the hood. So that's that's where I'm at now. And so right now I just have a sort of a else if statement to let me see. Oh, maybe I could bring the code up. Let me see, where am I in the code? Code.
You have a 5-second delay on startup?
I don't have that complication added yet. No.
I believe that's one of the requirements. When they say go, you've got
Oh yeah.
5 seconds.
Yeah, precisely 5 seconds. You can't be early or fast. And so basically, right now I just have just for this demo to test it. I just have a bunch of if statements in a row to make it do that motion that it's doing. But I still have to get it to go seek around and move around looking for the other robot and try to figure out any kind of movements to get advantages and stuff, and do the timer at the very start. So I need a more complicated state machine than if else if statements. So I'll be working on that state machine. But one thing I did do is I put the I2C bus and the IMU and the time of flight sensor on the second core. And because I was noticing that this takes a lot of time, and I want to be able to read the edge detect sensors and basically when I get close to the edge of the board, I want to instantly detect it and get away from it. So it has a really tight 0 delay loop, and this loop runs in about 1/4 of a millisecond. So I can run it at full speed and stop at the edge and back up without going over the edge. So to do that, I was noticing that the time of flight sensor was taking 50 milliseconds. I was trying to figure out why could I make it better and better, like reducing this delay, and it was just so I moved all that code over to Core 2 because the range sensor that detects the object, the other robot, it doesn't have to be kilohertzes. It can be 100 hertz or 50 hertz or something, and still work well. But the edge detect sensors have to be ultra fast to keep it from accidentally going over the edge. So this is the way you do Core 2. So I set it up and I initialize the I2C, initialize the time of flight, initialize the IMU, and then tell the other core that I'm finished, and then it can continue on. And then I put the I get the time of flight information and process the IMU in Core 2. So everything, yeah, it works good. I'm pretty happy with my setup here.
So the 2 cores don't run simultaneous. You go one and then the other.
There's 2 cores. They run simultaneously.
Oh, they do.
And so
they're both independent.
Yeah, they're just 2 cores.
Yeah.
And so right here is the atomic statement to make sure that I should have just made those Booleans. And Booleans don't really need to be atomic because they're atomic by nature, I think. But if you're doing processing on them, but our Arduino has an atomic statement that you can put on variables, and the only one I put it on is not that one. I'm looking at let's see. The count. So I got like a FIFO or a ring buffer, and I put a counter on it. It says, how many samples are in the buffer that I'm sending from the Core 2 to Core 1, and I made it atomic. And so that's my protection for multiprocessing, for really true dual core multiprocessing. So I did have a question for Tom. Let me put Sharon here. Oh, there we go. Tom, you said that you were working on you got some inexpensive BL53L5s?
Yes, I did get them. Working on them is a slight future endeavor.
Ah, okay. Yeah, because those would be those would be really fun to put on here.
Yes, and they were certainly cheap enough.
Yeah. So I was thinking those would work really good, and I could, well, it would give me an advantage over really simple ones. But I'm wondering, from a stealth point of view, what would defeat them? I guess I can't remember who was saying it, but like that foam, black foam would probably not work. Well, I think they would see the black foam pretty good. What they don't see is a shiny mirrored surface at a 45-degree angle. Because it'll just hit it and bounce off, and you won't, and it'll be invisible. So I'm not sure how you make sensors that are foolproof, but these IR sensors are very easy to fool.
I guess you can't have your mouse running around emitting little flares, right?
You could, yeah. You could have strobe lights or something. Maybe there's something about you can't do damaging stuff like fire or anything, but maybe you can blind the other sensors with strobe lights.
just stick a little one of those little sparklers on the top of it. That must last long enough for a contest, right?
A cheap laser,
Yeah.
Blind all your infrared sensors.
Yeah. So I was hoping to see Mark at the Dallas Makers Brace yesterday when I went there to measure it and to work on with the ring, just to see. Yeah, to see we play with a real robot instead of a box. But boxes are pretty good. They just don't fight back.
Need a real Pololu.
Is your front edge resting on the platform?
Yes. Yeah. Yeah, the very
it's sort of acting like a caster, the front edge of your chassis.
Yeah, this whole plane from here to the center of the wheels is flat, and it's 1 millimeter below the wheels. And so everything just hugs the surface except the back. And then I got a little wheelie on the back that goes up. So if someone tries to lift it up, it'll still get some traction. If someone tries to lift it up, I can still get a little traction because it stops here and then has an angle here to go. So I can do this. And then I can detect that with a IMU and go, oh, someone's mucking with me.
If you slide a flat sheet of white paper towards it on the surface, does it get under it? Try it with it on.
Why would that be a concern, Kareem?
That's a common strategy. Sheet of paper. You put a very thin sheet of white plastic on the front of your robot that's the lowest possible thing, and it can trigger the sensors if it can get underneath.
Oh yeah, nice. It'll eventually get under.
It'll back up as a result.
Right. Yeah,
you can force a robot to back itself up because it thinks that it's at the edge.
Yeah. So can you see it here?
Not really. Seems to be stopping it mostly well.
So it has to be really flat. If it's really flat,
it has to be super flat. And it has to be harder than a piece of paper, but yeah.
Yeah.
If you pull it sideways, like that, can you get it under? No, that's good.
And then when the wheels are pushing it down, it'd be even harder. Yeah, and most stuff will have some depth to it, like
So if you push the white paper under the sensors behind the wheels, will it try to drive off the edge? Which sensors are the most predominant?
Oh, well, the front sensors will make it back up. The back sensors will make it go forward.
So if you were to stuff the white paper under the back sensors while it's an inch away from the line, will it drive itself off the ring?
The front sensors will keep it from doing that because they have preference, I think. Yeah. So that's part of the state machine I got to design and like all that stuff.
Okay.
Yeah. But, if you can do like we do with the 3D printers, and when we're leveling it, instead of that big thick piece of paper you have there and that big thick ruler you have there, Post-it note. It's going to be a Post-it note's going to be about 0.2 millimeters, and ought to be stiff enough. You can slip that underneath there and get a nice clean edge. It's all rumpled edge, right? You don't want a rumpled edge. You want it as clean as you can. If you can get that underneath there, you get to go lower.
Oh, so it went under there, but
it went, guess what's going to happen? Your piece of plastic can go under there too.
Yeah. Yeah. So I need to really work on this and make it really. Need to sand this down really good.
Yeah. Defend against that. Yeah.
And then when the motors are driving forward, they'll push it down, so it'll be harder to get under.
And that's great. Yeah. So it's surprising what you think thin is, and then and now you find something that you got thin. That's pretty thin. No, that's not thin. That Post-it note is the reason that we always use it in the 3D printing world is because luckily Post-it notes seem to be like Legos, one of the most consistently made thing on the planet as far as things go. And so it's literally about 0.2 millimeters thick, somewhere between 1.15, 0.2, something like that, real close. And it's every time. So as long as you can, in our case, we use it to be consistent across when we're hand leveling it. Now you auto level and you don't need to worry about that as much anymore. But it made a real consistent thing. And so now I'm consistent. I'm like, if it goes off or on, we could adjust the Z up a little bit. But we know we're consistent to start off with.
Yeah. So the next time I make a body, because I need to make a new one someday, but that's maybe when I put new sensors on it, and definitely want to put new sensors on it. And I need to take this with a belt sander and sand it really flat.
I think your intuition is a little bit backwards on when the wheels are driving forward. When they accelerate forward, it's going to want to wheelie. It's going to want to lift the front up.
No, the wheels turn this way, and it'll force it down.
That's not
works
how it
that
works.
way on dragsters. That's why they have wheelie bars in the back.
And when it goes backwards,
always accelerations forward are going to create a wheelie. That's why wheelies happen. That's a function of equal and opposite reaction with the rotation applied to the wheels.
Did you ever see a motorcycle do a wheelie going backwards? It only happens going forward.
That's another reason why the competition ones will generally also, like that front wedge is often a steel sheet, right? Because that also helps to put more weight down forward.
Yeah, because I got the battery right here, so.
Yeah, but accelerations will cause it to wheelie up.
You could say it will really wheelie.
Really wheelie.
Let me power this thing up. Curious.
I still don't quite get the thing with the sheet of paper. I mean, it's going to be pressing at least at one point on the front of that chassis somewhere, right? Maybe 2 points.
It would usually be, if you're doing this competitively, you're usually going to have a slight curved front piece if you're trying to create a white thing at the bottom. It'll be curved more in the middle, so it'll just it'll sort of wedge from the center.
All right, got to think about that.
Just, think about
Make
drag
it
strip.
maximum acceleration and see what it does. If you are you limiting it or?
No, I'm running at max.
Okay. And the motors might not have enough oomph to lift it that much.
Oh,
That's good, Mike.
yeah.
That's a gold star.
Yeah, you're right.
Physics.
So that
Go
was-
figure.
Yeah. So I need more weight, and I need to put the weight in the front of my head, of my top, to push it down.
Hey,
So I need to
Kareem,
make a top with a bunch of weight here.
the point that you were making about the little short edge in the front, and I was trying to get the same point across, I think. Wouldn't it be better if instead of like a short lip in and then almost a vertical section up, that was either curved, very sharply at the end, or completely flat, so there's nothing to catch on? Because I thought one of the advantages
usually completely, usually completely flat is best, and you want it almost like a knife edge.
Yeah.
It can't be that long because you can't put a sensor there, and if that goes over the edge of the platform, like if it goes over the edge like that, then you're out. You basically you're out of the ring. So,
Well, okay. You see the vertical edge on the front part of that. I think another robot could push you back.
oh, this here, yeah.
Well, yeah, that section, because it seems like it could get up above the lip, but
Right.
still have enough, I don't know, I guess friction to be able to push you backwards, versus if you had a complete slope, or even, let's see, how would you say that? Yeah, I was thinking that Kareem was.
Because I didn't have any room in here because the sensors are right here.
Yeah. Okay.
The battery's here, and the wheels here, and the back sensor's there. So
Yeah.
so I couldn't, like, if I had more room, I would have pushed everything back and had more of a. I was thinking I want to put a slope here. But
Yeah.
I couldn't. and then I was curious. I was wondering, like, the front edge sensor, if it, I guess,
It's a little further back.
well, it's right here, so it'll see it at that point there, and then it takes a while to stop, so it goes to about here. But if you had something sticking out past that sensor, how would you keep it from going over the edge and being disqualified and stop and say end of run because you went over the edge out of bounds?
Yeah, well, the robot has to fall off the ring to be out of bounds.
Well, some don't. I mean, I was reading the instructions, and if any part of the robot goes over the edge, you're out. And
so, but what I've seen and understood is, if your robot is overhanging the edge and you're basically not off the table, like off the ring, and you can recover from it, it's good. It's when it comes off and it can't recover.
Well,
like the ring is usually up off the tabletop. So
I was also I was reading the basic original, and seemed like a good source of original instructions. And in this area of here, like the ring and this kind of stuff, it's subjective to be interpreted, and everybody can interpret it differently. But the strongest one is if anything goes over, you're doused. And
that's, I've only seen that applied in Japanese sumo. And if you're talking about competing in DPRG, we have rules that are published
Yeah.
for it, and
Yeah.
there, I wouldn't.
The person to ask would be
nobody's.
Mr. Doug.
Yeah, but
The rule
I don't
master.
think I've ever seen anybody ruled out just because, without like, at least tilting the robot out.
You
But
have
usually
to drop off the edge.
Yeah.
So we're not modifying, but we're adopting that rule. Yeah, that interpretation of the rule. So yeah, okay, that helps.
So life just got
Yeah.
easier.
Yeah, the robot has to be essentially unoperable on the table, as far as I know. So as long as it's recovered on the table, it's not falling off.
Right. Yeah. Because I had mine so that it goes to about here, and when it's running at full speed, and then it reverses back, and it never goes over the edge. So
Yeah, the way it is you see how there's thickness to the board. If
right.
it tilts so that it touches like that, then that's you're off.
and the wheels are spinning. Yeah.
And smoke's coming out the front.
Yeah. So, but my big problem right now is sensors. And so I was hoping that Tom would say, hey, those inexpensive sensors that are those L5 sensors work. And I go, oh, I'm going to redesign it with those sensors. I know that they're more power hungry, but this is a pretty big battery in here. It's the biggest one I could fit in there. And it'd be plenty of battery to run them.
So
in
you don't have a whole
practice,
bin
sensors
of
aren't always needed. In practice, sensors to detect your opponent aren't always needed. There's a strategy where you do have to detect the edge of the ring, but there's a strategy where you just go barreling across and then turn around every time you hit the edge, and then just go barreling across the other way. And if you do it fast and with energy, eventually you're going to hit the other guy, or they're going to come looking for you and hit you. But they're not necessarily going to be that much advantaged, because it is difficult to detect reliably. It's very difficult to do like continuous steering to the to the current location of the robot. So it's like I'd almost like put those on the back burner versus just getting your basic robot behaving very aggressively.
Yeah. So I need to come up with a state machine that has a lot of behavior to it that'll do aggressive stuff quickly. So
yeah, but you're like if you
turning-
do something like rotate in place to scan for your opponent, that's going to hurt you more than anything, because you're very vulnerable at that point. So it's better to just go balls to the wall, just go as fast as you can. And if you do get some sort of indication of a target shifting and or like being to your right or your left, you can steer while you're charging across the field.
Right, it can bias it. Yeah.
Yeah, but don't go and try to act like a
Don't go like
raging
this.
turret. Yeah, that's not going to work out.
So then what about having a sensor, one sensor on the front, one sensor on the back, one on the left, one on the right, and use those to target your, try to find your opponent while you use Kareem's strategy of just barreling across.
There's another thing that my students always run into is putting an appropriate boundary on it. And this is a case where kids are worse about it, because they start to get excited and they crowd the field, and the robot starts detecting people as targets at that point, right? Because they're bigger targets.
Oh yeah.
And so it'll start charging at them because they're just too close. Now adults will be suitably, well behaved and step away from the ring appropriately. But
Yeah, sure.
you do gotta worry about all sorts.
I don't know about that.
Yeah. Like here. Says, I go here and it's hitting the ring.
So take the Ramba approach, just, an old Ramba where you just head off in some random direction and look forward and see if you poke anything or hit anything, and if not, take another random direction.
Yeah, that's sort of what you do with the edge. Is you would go to an edge and then you'd turn around at a different angle and hit the edge again and go again. But if you randomize it, it might make it. I was thinking I would want to randomize it instead of making it totally predictable. But that's a big thing. It's like, okay, do I turn left or right when I hit the ring, or do I?
How about just back up?
Well, right now it backs up, but then I need a more complicated state machine to actually move it and go somewhere else. Right now,
you want to pivot to one side or the other, because you could be going that direction because you've got an opponent behind you and pushing you across the field.
Yeah, because right now I got it so that if this sensor hits the edge, it'll rotate this way. If that sensor hits the edge, it'll rotate the other way. So that's sort of designed in it now, but my state machine's not complicated enough to. Once it pulls away from the ring, it says, "Oh, I'm happy now." So it needs to have a lot of states to it. So now it's coding, because I think the robot itself is pretty good. I mean, it's not ideal, but it's pretty good. It could be heavier. It could be more durable. But I think it's reasonably okay. Pardon?
What are your wall thicknesses? Like what, 2 or 3 millimeters, maybe?
Yeah.
That's going to be pretty tough, right? Did you do it in PLA or ABS?
Well, this is in PLA, and I sort of like PLA, but I would probably want to try it in ABS, but I want it to be flat. So if I can find a matte black PLA, a matte black ABS or PETG or something. Yeah, and use the better printers at Dallas Makerspace. My home printers, it makes nice prototypes, but it doesn't do a great job.
How about just painting it? And a flat black spray paint goes a long way.
Yeah. That's another idea. It's just whatever material you got, and then.
You know, Angus, the guy is on 3D printer, and he's called. His channel is Maker's Muse. His first name is Angus. He does a lot of these BattleBot things over in Australia, and he builds he's building BattleBots that beat each other up, not the sumo thing. So maybe there's a different thing here. He builds almost all of his chassis out of TPU. Yeah. So you can beat on it. It's got give. So you can't. It's hard to tear that up with whatever little bit of. And they're pretty little nasty things running around with sharp edges, but still the way it's got a give to it, it tends to eat the kinetic energy and go instead of just taking it and flaking pieces off. So I don't know if that plays well in the sumo world or not, but I just figured I would throw that out there as a thought experiment.
Yeah, well. Yeah, they're not trying to beat each other up. In fact, you're not supposed to damage the opponent. It's just part of the rules. But I, on the very front here, see if I can set it up here. Let's see. The time of flight sensor, I was just showing how tight it is. Time of flight sensor is right here. And so if you can sort of see it on there. It's not focusing well, but yeah. So basically it's just right at the very top. This thing is well, using off-the-shelf components, it's full.
That's impressive what you managed to do in there. You built your own PC board essentially, or just point-to-point wiring.
Right.
But you fit it all in there.
Yeah.
You're ready for the next one, eh? What is it? Ant weight?
What?
That would be a custom board, I think.
That's actual BattleBots.
Oh, is that BattleBots?
Yeah, if you're talking about ant weight.
Okay, because I thought there was a class.
Type.
Yeah, below Sumo.
There's mini and micro. There's mini Sumo, there's micro Sumo, there's regular Sumo.
Yeah. But micro Sumos are half the size.
They're crazy small.
Yeah, and that's really custom stuff.
So the last meeting, somebody showed one that was an inch by an inch or something.
Yeah, 50 millimeter
Oh
square.
yeah, picture, yeah. Yeah. You notice on here the connectors that I use, 0.1 inch connectors, take up about half the circuit board. The white connectors there. So it gets
Well, it's either connectors or soldering and unsoldering constantly, right?
I like connectors. I've had to take it apart a few times. So and then I got my my USB cable that plugs in to the back. So on the back here I have the port.
Mhm.
And so I plug it in and it'll power up all the sensors.
Sword wizard.
Yeah. The motors won't run, but it powers the sensors up. So it's good for lots of debugging. Yeah.
What's the RP40 board that you're running in there?
Which one?
What's the RP40 board that you're running?
Wave Share 0.
It's one of the Wave Share ones.
Yeah. Yeah. So if you did I have that in my
I think it's on your schematic.
it's on my schematic. I was wondering if I had it oh, I don't have my processor yet. But yeah. But if I bring that up, let me Google it here. Okay, so let me try to share this screen. Share. Yeah. So this is the board here. Yeah. So that's the I/O on it. So I wasn't sure what your question was, but this is the board I use.
No, I was just curious which board you were using because it was a smaller board.
Yeah. And so I'm using this, both sides, all three sides. And if I go to my schematic, I gotta do the. Yeah. So I drew my schematic. Let me get rid of. Yeah, it is basically a physical view of the pins. So and then the components and the connectors are all physically oriented on the schematic. So this is the way everything's wired up, except the 3.3 volt regulator is over here. But you can see here that it I use all the pins basically.
So is everybody using the 2040s because they're cheaper than the 2350s? Where you're just used to it or had it in your box? Or
I had some and I didn't need the extra power for anything.
When it comes, there's a lot of secondary boards that were based around the 2040, and it's not until recently that they've started coming up with some of the auxiliary boards with the 2050.
Right.
2350, yeah.
Yeah, like the RP2040, using the programmable I/O, you can create two duplex, two serial ports on it. I mean, 4 serial ports, and you could add two more serial ports on the 2350, so you can have 6 serial ports using programmable I/O and 2 native serial ports. So you can have 8 serial ports on it in a package of this size.
Yeah.
So it's a pretty powerful beast.
Yep.
And it's perfect for this project because it can run this C code super fast, like the main state machine loop will be running at a couple kilohertz using the IR sensors and the other sensor data to sort of IR sensors will be used to hit the edge of the board and back up and turn and go hit the edge of the board, back up and turn and do just crisscross the board a lot. And if it sees the other thing using some of the range sensors, it'll veer towards that one, veer towards it. And that's sort of what Kareem was suggesting, instead of studiously looking for something, like sitting in one spot and rotating around and looking for something. You just sort of just bang around and make yourself hard to hit. And then if you have a good sensors, you can basically bias yourself to hit them instead of just randomly hitting them. So it helps. Yeah.
So I'm not familiar. I have never used the 2040s. So the diagram there, it shows, it looks like you've got UART 0 and UART 1. Are those the pins that you can put UART 0 or UART 1 on? But they're not, you can't do 4 separate ports, can you?
Yeah, let me bring this up. Like UART 0 and UART 1 you can only have one UART 0, one UART 1, but it can be put on any of these pins.
Okay.
There's
the designated pins there. So you couldn't go to like GPIO or GP2 and 3 and put UART 0 on it or something.
Yeah, but you could use the programmable IO for 2 and 3.
Okay.
And these are like the hardware ones.
Yeah. Okay.
So
they're not
running around a couple of megahertz, then it would work fine. Yeah. Actually, the PIO is hardware, so it could run really fast.
Oh, okay. So it's not like a soft serial port; it's an actual hardware port.
It's more hardware, and it can be DMA driven and that kind of stuff. It could be pretty complicated. So you can do a lot of shit with it if you have the right.
Well, you got 32 instructions, as far as I know, in the PIO. For each one, 32 PIO instructions, maximum.
Right.
For each PIO, and I don't know how many you can do.
Right. So just reading the library, the Arduino RP2040 for the RP2040, they say on a 2040 you can run 4 full duplex serial ports using programmable I/O. So you can run 2 of those on each of those engines. And the thing is, you're sharing the code. You can run the same code on multiple ports. Like you can have one code base and use the same code for multiple pin pairs and use dedicated variables. You don't have to have independent code if you're doing the exact same thing on all the pins.
Yeah.
Yeah, you can. It's sort of like a subroutine where you can just call the PIO and program that into it, and it'll run.
Right. Yeah. You grab the PIO, which is 32 instructions, and then download it into the PIO state machine, basically.
Okay.
Yeah, but you can replicate that same code across different PIOs.
Right. You can use that same code. Yeah, you can yeah. You don't have to have, like, if you're doing the same thing, you don't have to have two codes. So the 32 instructions could be all used for serial, and you could use it on multiple PIO pin pairs.
Okay.
I know the one for create a high-speed encoder inputs. So like for
those are
dual high-speed encoder inputs, and they do it in less than 32 instructions for basically both encoders, A and B pins.
Right, and then they're super fast, like yeah, I don't know how run they fast, but like it's like 100 nanoseconds of resolution, stuff like that.
Yeah, really haven't played around with use the ESP32s, and I think it's a small board like that one. It's either the C3, I think it's the C3 core.
So this is my processor of choice, and I've been using it on all my robot projects to date. Except the very first one I built was a different one, but ever since then I've done it with this and all of my microcontrollers, and they work great.
I was going to ask you why the RP2040 versus an ESP32 or something like that.
I don't like the Arduino IDE controlling the ESP32. It just, things are just weird. And I don't know.
Yeah, but that's so I use the VS Code for, you know, my Arduino boards and my ESP32s.
Yeah.
And you know, it's a lot of flexibility and it works well, I find.
Yeah, I was trying to figure out how to use the platform IO, and it seemed like their libraries were not as there wasn't. I couldn't find some libraries that I needed that would work on it. I didn't work that hard trying to figure it out, like a day or so, and I said, forget it.
Yeah, it's not as easy as the Arduino world to get libraries, because there are several different libraries that'll do the same thing.
Mm-hmm.
And some are just forks, you know, of another. But usually you can look at, in the Arduino world, you can find who made the library, and you find the name, and then you can find that same library in Platform IO. VS Code.
But I really like the PIO, the programmable IO for hardware-based signaling stuff. It's, to me, that's the reason I like to use them, is for that hope. And they do have RP2040Ws, which has a
right, and
as an extra chip. But yeah,
yep.
I don't know. Everybody has their own favorite, so this is my favorite. It hasn't let me down.
Yeah, the Picos are a really nice chip.
Yeah, and the 2350s are somewhat faster, like 50% faster, and has more hardware PIOs. So has 3 engines, I think, instead of 2.
Yep.
So a total of 12 pins instead of 8.
And it also has a bigger brother version of it that gives you a lot more pins.
Okay, yeah, I guess so, yeah. But on this package here, yeah. So that's okay. So let me stop sharing here, and that's my presentation.
Good stuff, Mike. Good stuff. You earned a gold star. Give us a good demo.
No hiccups.
No hiccups. Yeah. No demo.
Hiccup. Hiccup. I can't even see it. Whatever. Hiccup.
Okay. That was the end of the list of presenters. I don't know if anyone has opened it up to a roundtable, and anyone have any questions.
So Tom, are you going to get your? Oh, he's not there. I was trying to needle him to figure out if those inexpensive L5 kind of flights are good. So I'm expecting.
Tom is there somewhere.
I'm in another. I'm working on another computer problem in the next room too.
Hey,
multitasking.
Work on my problem. The L5.
Actually, I did have a question I was going to ask.
Maybe since I have her, good enough.
There was lots of fun discussion about the potential bulk purchase of the surplus
everyone's frozen
lawnmowers. I wondered how many people here bought one. No?
Not me.
Oh, Doug
Got
raised a
one.
hand.
Doug raised his hand?
Yeah,
I
I thought
bought-
Paul said there was 6 left.
And I
So-
bought some mowers.
Oh,
I
still.
didn't buy the whole thing though. Probably should have at $100, but
Pretty good
Wow.
deal for an outdoor platform.
Yeah, yeah. If I was starting from scratch, I'd go, I'll take one.
I was waiting to hear the details of what the conversions will look like.
Uh-huh.
So is that still going on then? I thought it was
last-
like an auction, no?
the
There's
last thing I saw was that they basically had it last weekend again. And after that, they're going to do an online type thing that they're not going, at the place.
there is
You
a
probably could contact the company and find out, online.
there's something on the list where there's an additional platform. I don't know anything about it, but there's some pictures. But so you should have had an email today, in fact, about another sale from Ross. And I'll tell you what it is here in a second.
Husqvarna's, I think.
It's a, oh God, that's HUSV, no, excuse me,
Husqvarna.
HUSQRAV robots. He says,
Tom was saying it right. That's Husqvarna.
yeah. Yeah, so that's they're going to do something. I don't think they've actually released it when they're going to do it, but they mentioned that if they're to see if anybody had any interest in them. Apparently, they were used to do some of their research.
That and his son's hatchet bot.
Mhm. Yeah, they're bigger. You know, those robots were bigger than you might have thought. I mean, they're a full-size mower robot. They're not itty bitty little dinky things.
They were probably 30 inches across.
Yeah,
He's
that's
right.
a
They
big
were
one.
not small.
Yeah, the biggest problem I think that I see with them is, you know, they're basically two big wheels in the back and a caster in the front. So that, you know, they'll be fine for the courses we've been running Robo Columbus on. But if we decided someday to do it in the woods, I don't think they'd be very good at that. And I don't think they would climb a step, for example, or anything weird like that. They do have an interesting bumper. They have essentially like a beam going through a circle, and if the bumper is kind of suspended so that any time it gets hit from any direction, you know, that beam gets broken. And so there's some cool technology in it. We'll see. I picked one. I picked up one, and we'll see how it goes. I did have something I wanted to mention to people, because I don't know if everybody's done all of their wishing Christmas stuff, but there's 2 sales going on right now that are about to end, and that I thought people might want to know about. One is let me see if I can share this. And these aren't cheap, but then again, on the other side, they're kind of cool. So let me. Why does it want to share?
Yeah, I was wondering if those robots have brush hog attachments, so you just mow down trees and brush and get it out of your way.
Okay, let me.
It's a thrasher mower.
All right, what do you? Okay.
You
One
might
of the
have-
things. One of the things that's on sale right now is from Bamboo. this is about, come on.
On the email I'm reading, he said that basically that the next sale they were doing was December says will likely be our last before we move to primary eBay for selling off unneeded parts. So you might check eBay.
So that was in an email from Ross Melbourne.
That was in the DPRG list.
Yeah.
Right.
Okay.
So anyway, let me, this is one here showing up on the screen. So it's the MEA Z1 desktop CNC entry. They still selling them at $900. I know that's a lot of money, and so that might put it out. But it looks like it's got really good reviews, and anyway, so that one's got 60 hours left on their campaign. I don't know why I can't find it. Oh, there it is. 60 hours to go on their campaign. And so anyway, if you've been thinking about it, this is something.
Is that for a mere $9?
Guys,
oh, never mind.
You know, be interested in. And then this is the one from, they still have their bamboo P1S, not the P2S, but the P1S, which is one that I've got for $399 if you don't get the AMS. If you get the AMS, I think it goes up to 500. Let's see. What does it say here? Yeah, 550. So that's a really good price for a bamboo printer. $399. If you know, I have AMS on mine, but I've not been doing any color printing. I use it just so for convenience. It's very nice to be able to just say, well, use this roll of filament or use that roll of filament. But anyway, these prices are, you know, like $300 off of what they were probably before Black Friday. Yeah.
I'll say one other thing in favor of the AMS. If you get it with the combo, well, two things. If you get it now with the printer as a combo, it's a lot less expensive if you decide you want it going forward. If
I gotta admit, you know, when I looked at it, I did get it with the combo.
Yeah,
I mean,
and even if you don't do multicolor printing, make sure you do multi-material, just like you were saying, Doug. It makes it real convenient. Like, ooh, I really want this out of PETG, or I want this out of something else, right? You get it, that's cool. The coolest feature for me, if you print a lot, is the fact that I can tell it. I've got 4 things in my AMS, and they're all exactly the same. So when it runs out of one spool, it'll automatically start using the next spool and go all the way down it.
That's awesome.
Yeah. And the thing is, they don't all have to be the same. Like, I routinely have blue, red, and yellow in my thing, and I've got 100 grams in one, 50 grams in one, 200 grams in another, and I'm like, okay, they're all blue. You know, printer don't know. As long as they're all PLA, or they're all the same filament that will stick together, it'll just sit there and fuse them all together and print them like it won't know any different. So you get to use all that filament up. I'm a big scrappy, you know. Yeah.
I have a lot of small partial rows.
Yeah.
And they,
you have a 3D printing addiction if you're printing that much.
Printers are just a totally different world, guys. I mean, you just push the button and they go. And I mean, if you want to use ABS, you want to use ASA, you want to use PETG, you want to use whatever you want to use, you just push the button and go. It's you know, and with the right nozzle, you have to change the nozzle. You can even do the material, you know, the reinforced carbon nylon type stuff. But I don't have any need for that right now. But I just brought it up because one's got like that CNC machine has got some really good YouTube reviews, and I'm real curious about it, and I'll probably spring for it. That's one of the things about being retired. You can buy shit like that. But anyway,
at least for a little while.
Yeah, at least for a little while. Well, hell,
So did you show a
how
picture
long
of
you
that?
gonna be around? You know, you're gonna be drooling when you're drooling, and you know you're not in there anymore. It doesn't matter. So anyway, I
So,
just
Doug, you said CNC machine. Is it a miller machine, a laser, or what? You said CNC.
well, okay.
And how much was it?
It's a CNC.
What is it?
It's an enclosed CNC, and because it's enclosed, they can make.
Is it a laser or a router? No,
It's a router.
Ah, okay. What size bed and what's the price?
It's what did I say? 800 or 900? Let me go look at it.
It's $900. The bed size on it is a little bit small.
Yeah.
How small is small when you say that?
I think I don't remember what the Z1 is.
Is it like 10 by 12, 10 by
No,
20?
it's less than that.
Okay. Because I had a couple years back got one when they had it on Kickstarter, and it was like $500, and it was a 10 by 12, and it was pretty good. And right now they have I want to say a 2 by 3 foot for like 1,500 for a router.
Yeah, this is
Okay.
most of those are. The nice thing about this one is this one will actually handle aluminum and stuff like that. It is a nice quality machine, but the bed size on it is pretty small.
Okay. So they're all typed out there. That's why I was curious.
Yeah.
Yeah, I'd say I somewhere they got the specs. I don't know. Yeah, it's a little on the when I see yes, it's slightly small. But
their Carvera Air, which is this one is their small entry level one. The Carvera Air is the one that fits into the that's their middle machine.
Yeah.
And that's the best bang for the buck.
Well, yeah, but that's $2,100.
Yeah, that's.
Yeah, so that's I don't know. The nice thing about these machines and the Carvera Air and this one both fall in that category is that you can have them indoors.
Yep.
You don't have to have them out in the garage. You literally can put them indoors. And you know, that is right now with the weather turning like it is, it sounds like a good thing, you know. I can't find the specs. I know they have them somewhere.
They're usually down at the very bottom.
Is that where it is?
How bad can the weather turn there? I had to shovel my way to my 3D printer.
Yeah, there you go.
Somewhere. This is all their add-ons and stuff. I don't know. Well, we'll just do this.
Anyway, if you go to Makera's website, you can find it too.
Yeah, I can just go to $200. So it's 200 is 8 inches by 8 inches. So, and I think the Carvera Air is I want to say it's 12, but I might be wrong.
I think it's 9 by 14.
9 by 14. Okay. Yeah, but this should be
bigger, and more importantly, which is really important with these, is it has a bigger Z travel. There's a Z travel of the Z travel. Because on the Z1, it's only 100 millimeters.
Yeah.
And when you're working with end mills and stuff like that, they take up a lot of room. So
Yeah. Well, we're going to see how it goes, guys, because I think I'm going to probably spring for one of these. We'll see. And
if you're making small parts, it's a good deal.
Yeah. Yeah. And I just like the idea of it being able to be in the corner and I not have to treat it like I can treat it like an enclosed 3D printer. That's nice. You know?
So I'm still at the bear skin and bone knives approach here. Here's my let's see, where's it? Video. My CNC mill.
Yeah.
Grinding away.
I remember you working on it. You've made some parts on it too. That's all you can, you know. Yeah. But
anyway, it's cutting a circle out for a bearing.
Yeah. Yeah.
Anyway.
Well, the other thing that was kind of interesting about this, I don't know about the Cavera Air. You might have, whoever was talking, they might know. This one actually comes with its own software.
Yeah, all the Make Era ones do.
Yeah, because that actually is a really hidden cost if you're not if you just buy a CNC, because the software is fairly expensive to get a good one. You know, you can easily spend $300 or $400 on the software. And anyway, that's
some guy
so that's
from
kind of
Malaysia,
cool.
I think, created the software for that. You could just download it. It was using, you know, the old ramps board.
Yeah.
Yeah.
So. Well, you know, it's not the G-code senders that are expensive. It's the actual CAM software.
Oh, okay.
You get where you get so, you know, you can say, well, I can use Fusion 360. Ugh. Yeah, you can. But there's other, you know, probably most of the people that own these types of machines use something like VCarve. So, yeah. But I don't know. We'll find out. So I just wanted you to know about those two opportunities to spend your money. I mean, to you know, enhance your game.
Give yourself a great Christmas gift.
Yeah,
you can always ask Santa for it. See what happens.
That's right.
So, Doug, do you have a picture of the mower that you got?
It's in a box.
Oh, okay.
Yeah. I'm not going to be messing with that one for a while.
So are they pretty narrow cut widths? Like, you know, I don't know, 18 inches or less or something?
I don't know any of the specs on it.
Oh, okay.
Yeah. I mean, I did, you know, one good sign was that apparently they work. A gentleman who bought one who lives next to Paul actually owned one of these machines, you know, from back in the 1800s or 20 somethings. And he just put the new one out there and let it go, and it did the job. So, you know, but they're like the original Roomba, you know, they just kind of crisscross all over your yard with no plan at all.
Oh, so it's totally random.
Totally random. Yeah. And it's you know, I don't know. I enjoy building my own platform. And so even though I didn't get it out this year, I did learn a lot of stuff, and that's kind of why I do this hobby. You know, and I think the last thing that I learned was that what do they call it? The creep that you have in making 3D plastic parts when they're using them to secure to an extrusion is kind of, the problem is you tighten them up, but then the plastic creeps, and then it becomes loose, and then it slips. So everything has to be anchored down. Even though you're using an extrusion, which probably means you're going to have to through screw it, or if you need something to slide for, like in my case, I have to have a chain. I actually have it the tensioner position so that even if the screws become loose, the chain doesn't come loose. You know, because the tensioner keeps it pushed. So there's, you know, I think that was the last big lesson I learned on it. I did learn one thing. I was so proud of getting those big tires. Well, it turns out that's not a cool idea, because if you have them, so let's say you have a tire like this, and I know over here you have a similar tire. Now you want to rotate in place. Well, you're actually skid steering. So you're moving all that surface area on that big tire, and all that surface on all 4 of those big tires, and that takes a lot of power. So the motors that I had were probably undersized, another problem. So I got to look around for the next step up on motors. I was using the 37 millimeter Polo motors, and they're underpowered. They work, but they're underpowered. So, or at least the way my setup was, they were underpowered.
Yeah.
I went to a narrow tire. That helped quite a bit.
Yeah.
Yeah. But unfortunately, you get the narrow tires, they don't really put treads on them. And so you do lose, now you have to have all sorts of, okay, am I stuck? If I'm stuck, what do I do? Type of routines in your software.
Yeah, I think that the ones that I have on mine are less than 2 inches wide, but they do have pretty heavy, frost cleats on them. And
well, I think you got much bigger motors than I have.
they're the 24-volt Go Builder with planetary gear heads on them. So
I'm gonna have to figure out. That's the next area I gotta just kind of like do a little more research on.
Yeah, they can spin it. I can grab the back of it and it'll fight me and try to continue to spin them. So they're pretty powerful.
Yeah. Well, I'm even playing around with these little bikes, little cars that people buy for their kids. Well, I think they're called Power Wheels. You can buy the Power Wheel motor gearboxes for very reasonable. They're not very expensive at all. And, if they can drive a little 60-pound kid around, they can definitely drive my robot around.
Yep.
So.
Yeah, Surplus Center had them, I think, for $12 or $13.
Yeah, they're not very expensive. And I found that on AliExpress, where I could get the same size motor with an encoder on the back. So I went ahead and tried those and tested them out. They look like they pulled pretty good. We'll see how that works. But that's kind of a back burner. If everything else goes to heck, I'll try that. I probably want to get some, like you said, some look into the FTC type motors that are available and see what they have. I also am intrigued about some of the if you look at what's the name of it? Rev Robotics Neo2 motors, which are brushless. Maybe Kareem can put some input. Can they be used as drive motors, or are they mainly for accessories? Kareem?
I'm sorry, I heard you mention me, but I didn't hear what kind of motor you were talking about.
It was the Rev Robotics Neo2.
Oh, those are amazing, but those are brushless. Those are more powerful than we get to use.
Yeah.
So they need a brushless controller, but those are amazing motors. They will drive any of the size robots that we have, you know,
Okay.
like crazy.
Yeah. Yeah.
And they're very you know, they're very good value for what they can do, but the cost comes in when you factor in the brushless motor controller.
Yeah. Yeah. Well,
You did say Neos, right?
Yeah.
Yeah.
Yeah. So anyway, that you know, something like that might be an interesting way to go too. Yeah. Let's see how it is.
Yeah, the ones that I had to knock a little kid off it, but you know, I eventually got it away from him. No, I found it was like a curbside thing. The batteries were dead on it, and there was enough of the motor shaft that stuck out of the back of the drive that I could put an encoder on it.
Oh, okay.
And yeah, those were pretty powerful. And they, you know, basically there's just the final drive is a plastic gear that rotates around like a 1/2-inch axle, and there's no bearing there. It's just, you know, plastic on steel basically that supports the weight of the toy, and you know, spins the rear wheel, or spins that wheel.
Yeah.
So
well, didn't you get some of those ones that you ride on where, you know, I don't know what you got them at Goodwill,
like Surplus Center or something?
Goodwill or something. Do they have hub motors, or are they just brushless motors?
Oh, you're talking about the hoverboards?
Yeah.
Yeah, they're 3-phase brushless motors.
So they're not a hub motor.
Basically it just you have an axle that sticks out, and you can mount that axle to anything. So yeah, it is the motor is in the wheel.
Okay, so it is a hub motor.
Yeah.
That's an interesting idea too, because those have got to be able to handle 150 pounds at least.
Actually, I think believe it or not, they say like 220 pounds.
Wow.
Yeah.
Okay.
Yeah. I found a couple. There's this one weighs a ton, and it has huge wheels on the damn thing.
Mm-hmm.
And this thing probably weighs 30 pounds. But yeah, on the back of one of these, it said it would handle like 220 pounds. So I think this one is a 10-inch wheel, but the other way, and these are actually pneumatic tires on the stupid thing. You know,
that must have been a high-priced one.
Okay, like a 9.5-inch wheel, not quite 10 inches. But the other ones are smaller. This is one from, oh shit. I took the screws out of it at some point. I'm dropping screws. Anyway, much smaller wheel on that one. That one's probably 6 or 7 inches in diameter.
Mm-hmm.
But yeah, they make pretty cheap drivers for them. Let's see, that one is like a 6.5-inch wheel. and it's got the motor drivers in it. Haven't I guess people have hacked into these and tried to figure out, how to reuse the motor drivers in them. So basically each side has like a tilt sensor and has the guy falling off its sensor. So there's like little, when you step on the thing, there's like a switch on either side to let you know that you're still riding, and as opposed to, getting tossed off it. And then you tilt your foot forward, that makes it go, faster, more and more, the more you tilt it, and same thing backwards. So, as far as I know, I don't think there's any feedback. So you could, if you drove it hard enough, you could lose synchronization. So, and that's like a stepper motor. It'll just kind of bounce around and not be in sync with whatever waveforms you're trying to drive it with. So.
Well, that's a whole new, that would be a whole, I have used them in RC cars, but I haven't used them other than that.
Yeah.
Yeah, and then the ESCs that they have for those are usually pretty good.
Yep. Yeah.
So, Kareem, how many can you use? Just a standard ESC? Like a RC ESC on one of those Neo2s?
I think
no.
Huh?
No.
I don't think so. Well, if it's a brushless ESC, possibly.
Yeah.
Yeah.
It's possible. Yeah. You won't get all of the features, but they have do they have encoders on them?
Well, they have, you can buy brushless ESCs, but you can also ESCs, but you can also get censored ESCs. So I don't know if they
definitely have the sensor wires available on those motors. So you probably want something like that. I don't know if they also have encoders on them. Kind of thinking they don't have encoders on them.
Yeah, I wouldn't. You probably don't need them if they're censored.
Well, you can still get even better performance if you also have encoders. Much more precise position keeping and things like that.
Okay.
At full torque.
Yeah, so one's more like a tack, and the other one would be true dual.
Like if you wanted to do CNC or something like that, you want a proper closed loop system.
Yeah. Yeah.
Well, I guess, isn't there like 2 levels of feedback? You can have Hall effect sensors that tell you when, the phases are changing in the motor itself. And
yeah, that's censored. That's the censored style, but then you can have full on encoders as well.
Yeah. Right.
Yep. And you can have sensorless, which uses the back EMF on the motors.
Yeah.
But those are all like features that if you get them all bundled together, you're talking about higher end motor controllers.
Yeah, I think the ones that I found on AliExpress, it actually used the 3 Hall effects inside, and for that particular motor, I guess just based on the number of poles it had, you got 48 pulses per revolution out of it. So you could use that, I guess, as kind of crude, as a crude encoder. Not a lot of counts per revolution, but of the wheel. But you could use that as positioning feedback if you wanted to.
Yeah, most times you just add an external encoder if you want an encoder on them.
For just a drivetrain, you often don't need to go that far. But if you're building like a arm or something like that, you might want a proper high count encoder.
Right. Yeah, if all you want to do is use them as a drive wheel, you can actually just use the like an RC ESC on them.
Mm. Yeah, they're pretty cheap and they can handle pretty high currents.
Yep.
Higher voltages. Yeah, I had taken the wheels off another hoverboard and mounted them on a frame, and was able to drive the two motors independent of each other, and with feedback, and it worked pretty good. It kind of, it's like got onto the next shiny thing and didn't do much with it after that. It's still sitting here on the table. So, but it looks like it'd make it a pretty good, outdoor robot. The axle isn't very thick. If I had to guess, maybe 5/8 of an inch in diameter. So you've got pretty good ground clearance, even with the smaller wheels. The wheels don't have a lot of tread on them. I think they're meant more for, going on like concrete or flat surfaces, hard surfaces. So I don't know, there might be an issue with, wheel slippage on, like Steve's property or something. So, but.
Well, a lot of toys to play with. We'll see what happens this next year.
Too many toys.
Yeah.
Possibly not enough time.
Yeah.
So speaking of toys, on that CNC, I found the thing that I was talking about. So let me share a screen. One second. Because, this is what I was talking about.
Well, this is, that can't do, that's pretty much restricted to wood. You can't.
No, it depends on what you want to put on there. You see, the key is what you put right there on that head. And that's the beauty of it. It's you can put in almost anything on it. So, see, I mean, basically, you can put what your head you put there is what determines that. So, assuming you get one of those, more powerful things, you can put that, and they're priced very reasonable. I mean,
well, it's not just what kind of spindle do you put on it. It's also the torque it has to go X, Y.
Right, and notice there it doesn't use belts. It actually it's thread. It has torque, and that part too. That's why I say it's well built compared to the first one. I got their first one, but even then they had that concept going. So that's why I was saying, and they had come up with even more. Hopefully if I click here, you'll see this next page.
Yeah, I think one thing too
threaded rod, or is it?
Yeah, it's threaded ball, threaded rod type thing. And they have a new
lead screw.
Recirculating ball, maybe.
A true lead screw.
And they even have even a more heavier,
most of them
bigger version
use a
now.
lead screw. Use a 8mm lead screw because those are common and cheap.
But you can see
That's
there.
lightweight though for a milling machine. I mean, it depends. I mean, you could go slow and take
and that's the key.
Deep cuts, but
you're not going to crank it out in 2 minutes flat. I mean, anything. That's the beauty of a CNC machines. You can go slow and
Yeah. I guess the other thing too is the rigidity of that frame. If there's any twisting or how flexible are the frame members, because that
if it said it has 8mm rods in it, you're probably not good enough.
Yeah, that's pretty lightweight.
Pull exact dimensions, but as I said, they have gotten small and big versions. So Lawn mill is the one we're after.
Yeah, there's a lot of different options now. It seems like this is coming on, but these like this like the Cavera Air, and then the other one, the one with the tool changer, that's their top of the line, I think. That one is that's really expensive.
Okay, it's
But I, you know, we'll just have to see. I don't know how when you actually use it, how big do you normally use it for?
Right, and that's
You know,
part of the key.
if you find yourself trying to build parts that are always bigger than 8x8, obviously you're going to have a trouble. But if you're
Well, like I said, the limiting factor on that one actually isn't so much the 8x8. It's that 100 millimeter Z.
Yeah.
Right.
Well, I think with that particular spindle, I think you're pretty much limited to, well, they want you to use 1/8 inch bits.
Right.
Okay. And that my preference is a 1/4 inch bit with, even if it's an 1/8 inch bit, I like a 1/4 inch shank. And they do allow that. But so we're going to see. And if you're cutting aluminum, and you don't want to have a mill that's 3 inches long, or anything like that. You want something that's short because you want rigidity.
Yes, but you have to remember that you're not only talking about the length of the bit, but if your material sticks up an inch,
right,
then that's taking an inch out of that 100 millimeters. And then you have your bit on top of that.
Yeah.
Now this one has a 4 and whatever,
then you even have even less space.
Yeah. Yeah, that's like but I also have a little shoreline mill, but it's even, so it's got plenty of Z, but its X and Y aren't as that big.
Right.
So we'll see.
Then you have to remember your work holding takes up space too, depending on how you do your work holding.
Yeah.
Right.
Yeah, this one does have a nice. It does have that Cavera style work bit changer. That's nice. That's really nice.
Yeah.
And it also has auto leveling, which is nice. So you don't have as much trouble with bit to bit changes and stuff. But anyway, let's see.
I don't know how much a DSC membership is now, or Dallas Makerspace rather, but you could pay for a membership and use a Haas machine and hog out with 3/4 inch bits if you want.
Yeah. Well, I don't think I've never had enough ambition to. That's great.
And by the way, Doug,
but isn't there a front part? There's a front part too.
Yeah, but the front part is not all it says on the front is what does it say on the front? Not much. That's the back.
Can you send me that picture and the front picture too? Because I'm putting
grab that picture. You should be able to grab it off the screen there, right? But yeah, I'll dig.
Give me a second. I'll try it. Because I'm just putting it on the website in our history section.
Right. And I'll drag. Yeah, I'll see if I can track down and send it to you. But, okay, so that's the back, and then I'll turn my camera on. Where's camera? Oh, come on, camera. Turn camera on. There. And then the front was this. See, so it was as much on the front.
Can you share that like you did the other one?
Do I have that?
So these are special edition Moon Day only T-shirts, or
I assume that you can't get them now, but probably.
Yeah, they were.
I mean, there was that company that makes them So who knows? They may have them on forever.
So where'd you get them from? So just some
I
guy.
forget. I would have to dig out the link that Eric had posted.
Okay. Hey,
So it was Eric.
Hey, John, can you put that front on there for a second?
That's why I'm.
That's the back.
Digging right now. Oh, where did I put that? I had the back. Well, okay. In the meantime, talk while I dig on some other subject. I'll dig it. Had it somewhere.
I think Doug wants you to hold up the front again to your camera.
Oh, well, I can do that easily.
Yeah.
If that's what he's after.
Yeah. And share it so I get a big picture.
Or you can just pin him.
Yeah. That's good. Up a little higher. Higher. Okay, stop.
Okay, don't breathe. Hold your breath. Continue to hold.
Okay, thank you.
Okay.
You can exhale now.
Yes. Well, the problem is you can't see when you're behind those strings.
Yeah, did you there was a couple pictures that were taken in at Moon Day this last time. And I don't know if it was just after lunch or the light was shadowing just right or what, but let's put it, well, you could say it highlighted your midsection, you know.
Well, that's always a problem for some of us.
Always a hazard. Yeah. There's some big shadows cast in that photo.
Yeah.
I'm just glad I wasn't in it. So
I found the high color post that Eric sent out. It was May 26th.
May 26th?
May 26th.
So does that have the link on that?
It has this has the logo on it. I don't know if it has the.
Well, it was a company that,
There's a PNG. Looking further down.
I forget the company's name. That's why I said you might buy the shirt. So yeah, for all we know.
Zazzle. Was that it?
That sounds probably right.
Yeah. There's a link to purchase the shirt from Zazzle.
What happens?
So if you look at the thread begins on that day I gave you, but June 8th is the one that has the full artwork of both front and back, and the link to is
Zazzle
site.
selling it?
And it's still available for $25.
She has a stack this high she'd like to get rid of. Yeah.
I suspect they print them on some computer whatever thing, and they can probably do it individually, which is why I'm not totally surprised.
I just posted the link.
Yeah. Kareem, do you have the pictures in the email?
Yeah.
Can you just copy it and send it to me?
Sure.
Yeah, because I don't find Eric's message.
Doug?
Yeah.
I just forwarded it to you.
Okay, great. Yeah. Cool.
Well, a penny weighs 2.5 grams, so I could add 100 pennies to the top of my robot to get it up to 500 grams.
Is that a modern penny? Because
Yeah.
it's not copper anymore. It's much lighter.
Yeah, like the older versions are 3.1 grams and the newer ones are 2.5 grams.
You need to get an osmium coin set of coins. Then that's twice as heavy as lead.
Yeah, but yeah, mini sumo you can build it as tall as you like. It just becomes top heavy.
Pennies are also going to be a collector's item soon.
You may not be able to find 100 of them.
I got a big jar full. So.
They have been in Canada for, I don't know, a decade. They stopped making them a long time ago.
Ah, smart Canadians. Yeah.
So what, you have a 10 cents then, a quarter? Or
Yeah, we got a nickel and a dime, but no pennies anymore. And they round up or round down, whatever the closest is.
well, they round up probably. Some things have gotten to that stage.
No, so here it has to, it's either or, it's the closest. So they round down or they round up. And it's not a voluntary thing. That's it. So if you pay by debit card or credit card, you're charged to the penny. If you pay cash, you're rounded up to the nearest 5 cents.
So you're saying that the companies actually do cents in there, then on their
pennies still exist,
right?
So they
on paper,
digital pennies.
So if you pay with a debit card or credit card, you're going to pay down to the penny out of your account. Right. If you pay with cash, they're only going to give you up to closest 5 cents.
Right. Or how much motivation people have to buy cash for that reason. I can see where you can save money or spend money.
So I got something to do with my pennies. Yeah.
Well, guys, it's 10 o'clock. So adios.
All right, good night.
Good night, everybody.
Yeah.
Mike, that was a great robot show. I'm really looking. Are you going to give them some trouble?
I think Mike left.
Yeah.
Yep.
So did I think Doug.
Yeah, good night, guys. Well, good night.
See you again.
Good night.
Well, I admit I was looking for a Canadian equivalent to the lawnmower deal, Pat.
Let me just stop the recording here.